Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful. Assalamu alaikum wa rahmatullah. The subject of this series of lectures is topographic maps. It consists of 3 parts. Part 1 gives general outlines of topographic maps. Part 2 demonstrates manual drawing of topographic maps. And Part 3 deals with computer drawing of topographic maps. Part 1 General outlines of topographic maps. 1. Introduction. The line that connects points of equal value is called a contour line or isoline. If the points represent elevation of the ground surface, then the line is called topographic contour line. A topographic map is a small-scale representation of an area, usually drawn on a sheet of paper. It reflects the landscape features, that is to say, topography, through the use of contour lines to visualize the vertical dimension on a two-dimensional drawing. A typical topographic map of an area ought to contain 1. The longitudes and latitudes and the directions of the true, that is to say, geodetic north and the magnetic north. 2. Scale, which represents the ratio of the image on a map to its true size on the ground. It may be expressed as a ratio, for example, 1 to 100,000, 1 centimeter equals 1,000 meters, 1 inch equals 10,000 feet, etc., or as a bar scale, or both. Large scale map shows a small area of the ground with greater details than a small scale map which shows a large area with fewer details. 3. The contour interval, which is the difference between any two successive contour lines. The choice of the contour interval depends upon relief, degree of accuracy, scale, and extent of the area. The relief of an area is the difference in elevation between the highest and lowest points in the area. In general, small contour interval will give rise to larger number of contour lines that may mask the features of the map. On the other hand, large contour interval will produce small number of contours that may not quite reflect the landscape of the area. The values of the contour lines that are usually used in maps are 5, 10, 20, 25, 50, etc. in meters or feet. Note that the values of the contour lines must descend to 0 upon continuous subtraction of the contour interval value. 4. A legend or key of the symbols used in the map. 2 examples of topographic maps are presented in figures 1 and 2. Map figure 1 shows Lagotarelli Island, which is 4 kilometers west of Horseshoe Island in Margaret Bay, Antarctica. This high relief island with the highest peak of 288 meters is nearly 1.8 square kilometers in area. The map scale is shown as a bar and the contour interval equals 20 meters. The United States Geological Survey USGS map of the Mount Massive Quadrangle, Colorado, is shown in figure 2. This large size map represents an area of about 150 square kilometers, 10.8 kilometers by 13.9 kilometers, with a scale of 1 to 24,000, has a contour interval of 40 feet. This figure shows the map sheet of figure 2 as it appears in full under a magnification power of 20%. Let us magnify the lower right corner of the map and see how the contour lines and map features appear under different magnification powers. Development of topographic maps. Since the early 19th century and thereafter, topographic maps were created on the basis of field data obtained by surveyors using plane table and telescopic alidade. After the Second World War, the use of aerial photographs to prepare topographic maps increased rapidly. New instruments were invented and new techniques were developed for this purpose. With the development of digital computers, digital forms of topographic map data becomes widely in use. In digital forms, topographic map data can be combined with other types of maps to produce specialized maps. Different scanning techniques and software tools were developed to produce highly accurate topographic maps with various scales. Laser airborne scanning are used for the derivation of digital terrain models for the description of Earth's surface. Airborne laser scanning, ALS, is rapid and becomes more reliable, and in many cases the only way to collect data of the actual surface in remote areas. Applications of topographic maps. Depending on the area, topographic maps may show mountains, valleys, plains, streams, lakes, shorelines, roads, etc. Thus, they are very useful in a variety of applications. They are widely used in geology, agriculture, irrigation, natural resources, and environmental studies, engineering constructions such as roads, industrial sites, buildings, recreational areas, among other fields. Manual drawing of contour lines. In order to draw topographic contour lines, we need to have a number of points whose locations drawn on a base map or in terms of XY coordinates and elevations, Z coordinate, are given. Then, by interpolation, new secondary points whose elevations coincide with the required contour values are located. Let us consider, for example, Figure 3a, where the locations and elevations of 4 points, say A equals 50 meters, B equals 45 meters, C equals 55 meters, and D equals 70 meters, are given as shown. Now suppose a contour interval of 5 meters is chosen. Then, between points D, whose elevation is 70 meters, and A, whose elevation is 50 meters, in the figure, 3 contour lines will pass whose values are 65 meters, 60 meters, and 55 meters respectively. Between points D and B, 4 contour lines will pass, and so on. Thus, the distance between point D, whose elevation is 70 meters, and point A, whose elevation is 50 meters, is divided into 4 equal parts, and the interpolated points have the values 65 meters, 60 meters, and 55 meters respectively. See figure 4. Accordingly, by interpolation between the 4 adjacent points of figure 3a, the locations of the secondary points whose elevations are multiple of 5 may be obtained as shown in figure 5. The next step is to connect each set of points of equal elevation by a contour line as shown in figure 6. It is to be observed, however, that the interpolation is based on the assumption of uniform slope between adjacent points since they are near each other. However, because of the nature of the surface of the Earth, as the distance between any 2 points increases, the irregularities of the ground surface are expected to increase. Accordingly, the assumption of uniform slope becomes weaker as the distance between the considered points increases and may lead to erroneous interpolation. Rules of contour lines. There are certain rules that apply to contour lines, which one should remember before starting manual drawing a contour map. 1. Since the contour line represents points of equal elevation, then every contour line represents only one elevation. The elevations of contour lines are taken with reference to a certain datum. The mean sea level MSL is the usual universal datum for all elevations, positive above sea level and negative below it. However, if an alternative datum is used, then its elevation relative to the MSL must be stated. 2. A contour line does not split or intersect another contour line. However, in the rare cases of vertical cliffs, coincidence between contour lines of unequal values may occur. Moreover, in the rare cases of overhanging cliffs, crossing between contour lines may also occur, in which case the hidden contour lines are drawn dashed. 3. A contour line is a closed line. If it doesn't close within the map, then its two ends must join and close somewhere off the map. Figure 7. 4. Closely spaced contour lines indicate steep slopes, whereas widely spaced contour lines indicate gentle slopes. Figures 8a and 8b. Five. Contour lines form a V shape pointing upward when crossing a stream or a valley. Figures 9. 6. Concentric circles of contour lines indicate a hilltop or a mountain peak. Figure 10a. 7. Concentric circles of hatched contour lines indicate a closed depression. Figure 10b. Manual map drawing exercise. Figure 11 shows a hypothetical map in which the locations and elevations of a number of points are indicated. It is required to draw a topographic map using a contour interval of 5 meters. As may be noticed, in simple laboratory hypothetical exercise maps, such as this one, the most important things to show are the scale and the direction of the north. However, if the map represents a real area, then the longitudes and latitudes must be shown. Manual drawing of the exercise map will be given in part 2 of the lecture. This is the end of part 1. Assalamu alaikum wa rahmatullah.